All right, part 2, rationalizing technique. So again, we want to make sure that we have an indeterminate form, okay? So we want to make sure that we get a 0 over a 0 to begin with. And when we rationalize, we're used to rationalizing the denominator. So you've always heard, 1 over root 2. How do you rationalize the denominator? You multiply top and bottom, and basically it just moves the radical out of your denominator. But we can also rationalize the numerator. So this is rationalize denominator. So what happens if I had a root 3 over 4 and I want to get rid of the root 3? I'm going to still multiply root 3 to both top and bottom, and I'll get 3 over root 4 root 3. So again, I can rationalize the numerator as well. Okay, so that's what's new in this problem. Okay, so let's walk through our very first example. Okay, so we're going to say the limit as x approaches 0 of the radical x plus 1 minus 1 all over x. So the first thing I'm going to do is I'm going to plug in 0, see what happens. So this will give you 0 plus 1 minus 1 all over 0. Already it's not looking good. So 1 plus 0 is 1. So root 1 minus 1 over 0, which is 1 minus 1, which gives me 0 over 0. Not going to work. Now, again, we can make a table, but we want to try to simplify our life a little bit more. Okay, so how do I rationalize? So I'm going to take my original problem, so x plus 1 in the radical minus 1 all over x. And normally we rationalize by multiplying by the conjugate. So the conjugate is your x plus 1 and then plus 1, right? So the second term is always the opposite. And we still want to multiply by a fraction of 1, right? So multiply by conjugate. All right, so a lot of times this limit, we have to take back some of the stuff that we've used in previous chapters. Okay, so the radical and the radicals are going to cancel away, leaving you with, not sure why my pencil is doing that, leaving you with just x plus 1, and then the radical times a positive, so this will be a positive radical of x plus 1. This will be your minus radical of x plus 1, and then negative and a negative, a positive are going to keep it with that. Now for the denominator, I'm going to go ahead and I'm not going to worry about multiplying in quite yet. So I'm going to leave it alone. So these two are going to cancel each other out, and the plus 1 and the minus 1 are going to cancel each other out, leaving you with an x, and then your denominator. And now, I needed to get rid of that x because I already knew that that was going to make my denominator not become, make my denominator become 0. So I'm going to take those away. And so I just get 1 over x plus 1 plus 1. So this is my new problem. So I now have a new limit as x approaches 0, and it'll be a 1 over the radical x plus 1 plus 1. So now let's see what I can do to plug in my value. Okay, so I'm going to plug it in. I'm going to say 1 over 0 plus 1 plus 1. I now have 0 plus 1, so this will become a radical of 1. Radical of 1 is just 1, and 1 plus 1 gives me a half. Okay, so notice that I, instead of rationalize the denominator, I rationalized my numerator. Okay, so that's what makes this situation just a little bit trickier than before. All right, let's try another one. All right, so go ahead, try this one on your own. The limit as x approaches 0 of the radical x plus 9 minus 3 all over x, and see if you can come up with the correct answer. All right, so if you try pausing the video and you work this out, kudos to you. If not, no worries, we'll do it together. So 0 plus 9 is 9. The radical of 9 is 3. So 3 minus 3 is going to give me a 0. I'm going to get 0 on the top and on the bottom. Not going to help me out. So indeterminate form. So I should have multiplied by the conjugate. So this would become x plus 9, and then a plus 3, and then x plus 9, and then a plus 3. So what am I going to get? I'm going to get the limit as x approaches 0. Technically, you should be writing this out each time. I'm lazy, and I just do it at the once I've figured everything out. So x plus 9, this will be a minus 3 x plus 9 with the radical, and this will be a plus 3 x plus 9 with the radical, and then minus 9 all over x, and then our lovely radical, and then the plus 3. Those are going to cancel away. These are going to cancel away, leaving you with just an x over x with our radical. X's are going to cancel away as well. So the limit as x approaches 0 will be 1 over this lovely denominator. So now I should be able to plug in. So I'll do it in blue. So 1 over 0 plus 9 under the radical. So 0 plus 9 is 9. The radical of 9 is 3. And 3 plus 3 is going to give me 6. So my answer should be 1 over 6. And that is your rationalizing technique. So we're going to switch gears. We are going to use technology, and we're not going to focus too much on this one, just because not a lot of people have access to all of the technology. So basically when we use technology, it means that we can't divide out, we can't rationalize, and we're just approximating our limit. So approximating a limit. Okay, so here's our problem. So the limit as x approaches 0 of this problem, 1 plus x to the power of 1 over x. So here's my dilemma, right? If I plug this in, so 1 plus 0, first of all, I'm going to get 1 in my base, and then I'm going to get 1 over 0, and that is undefined. So I'm basically trying to raise 1 to a power of undefined, and that seems like it should be nothing. It should be 1. So there's no dividing out. I can't take something away. I can't rationalize anything. And so this would be an example of where we'd want to use technology. So I'm going to come over here to my lovely calculator, and I'm going to go to my graph. So take away that. So this will be a 1 plus x, and then to the power of 1 over x. Okay, and so let me see what my graph kind of looks like. It looks all weird. So it does look like it's approaching something when I do get some sort of answer when x is equal to 0. So my graph does show something. I can zoom in. So let's zoom in a little bit. So did I zoom too high? I did. So if I change my window, so it looks like I need my max window to be, let's do 4. Let's make my x min 0. All right, that didn't help too much. Oh, I changed my x-axis. That's not what I wanted to change. So let's go negative 0.5. I want to change my y value. Let's change that to 0. We'll change that to 5. All right, cool. So 1, 2. So it's in between 2 and 3. So if I use my trace button, I can try to get close to it. So tracing. So it's like 2.7 something. I feel pretty confident with that. 2.7 something, something, something. So let me go to my table. So again, there's an error. So I want to make sure that I plug in a 0, and then I'm going to change my settings on my table. So table set, and so second table. So instead of, so I'm going to start my table at 0. Instead of going by ones, let's go by 0.0001. Let's see what happens when I do that. and then second table. Okay, so notice that again, as I get closer and closer to the number 0, it gets about 2.7181, 2.718184. Now, how I can use my my two tables, because these are still kind of far apart from each other. What I can do, so it was 2.7184 and 2.7181, I believe. Yeah. And then, so there's two numbers. I'm just going to take the average of those two numbers. Okay. So quit out of that. So 2.7184 plus 2.7181. And that gives me that. I'm going to divide that by 2. So I get 2.71825. 2.71825 as my, again, approximate answer. Now 2.71 should remind you of something. And hopefully you see it on my calculator. It should kind of remind you of E. So we're off by just a little bit. So again, the closer we got to 0, I think we would have gotten closer. So this limit as x approaches 0 is actually E as our answer. But this is just another example of how we can use technology when we can't divide out, when we can't approximate things without using technology. Again, we're not going to focus too much about this. We're going to focus on the dividing out technique and our rationalizing technique. In the next video, we're going to talk about one-sided limits.